Hi, Mrs. Zooey.
Hi, Miss Gray.
It's so good to record a podcast with you again.
Yes. It's been a while, huh?
Yes, it
All
sure
right.
has been.
Mhm.
Today we're going to work on the solubility rules.
Solubility rules.
And this one's not too bad because the kids have their naming card.
Oh, yes.
So they're going
That's
to
why
be,
it's a lifesaver.
they're going to be
They
so
need-
good at this.
They need to have that.
Yep. So let's look at forming ions.
Forming ions.
Remember ionic compounds?
Yes.
They have a metal and a non-metal
Non-metals
together.
together.
All right. Well, now we're going to tell them the other name for ionic compounds.
Salts.
Yeah. An ionic compound is called a salt.
Yeah.
Most of our kids know about this one. Sodium chloride.
NaCl, yeah.
Right, because they
Very
sprinkle
common.
it on their food and eat it.
Exactly.
But all ionic compounds are called salts
Why?
because we put a positive ion with a
Mhm.
negative ion. But why did they ever use that word salt? I don't know.
Yeah.
I don't know the
Well,
history.
just remember, positive ion, negative ion.
Right. And of course, if we had a molecular compound,
Mm-hmm.
it doesn't break apart into ions,
Yeah,
right? Because it's
Yes.
not made of ions.
exactly.
Right. So it's a metal with a nonmetal or a metal with a polyatomic
Polyatomic
ion. Hey,
ion.
see, there's that word, ion.
Yeah. that's-
ionic.
All right.
Here's some examples. Sodium chloride
Mm-hmm.
and sodium chlorate and lithium carbonate.
carbonate.
Yeah.
I need my card, Miss Gray.
I know. I have to memorize this for AP chemistry.
Oh,
yeah.
They
So-
challenge you, huh?
They do.
Yeah.
Polyatomic ions, of course, are on your naming card. So
Okay.
we
Remember
get to
that.
use that card.
Yeah.
Well, let's talk then about what do we mean by being dissolved?
Dissolve. Like when you put salt in water, Miss Gray.
Right, exactly.
Yeah.
So if you see this notation AQ, it stands for this word aqueous.
Aqueous, meaning they dissolved in water.
Right, right.
Yep.
Do you speak Spanish?
No.
No, me neither. But I hear there's
Aqua.
a word, aqua, yeah. See?
Oh, yeah, I
I
remember.
can remember. Yeah, Latin.
Aqua means water.
Right. And for salts, if it's listed as aqueous,
Mm-hmm.
that means it's not in a molecule, it's actually in the
In
water,
ions.
in ions.
Yeah.
Right, as charged particles in the water. So if
Example.
you see this notation, NaClAQ, that means we have sodium ions
Mm-hmm.
in the
Plus,
water.
Yeah.
We have chloride ions in the water.
Yep.
That's what it means.
Oh.
Okay, so acids would break apart too.
And it will form ions too, right?
Yes. So hydrochloric acid forms hydrogen ions
Mm-hmm.
and chloride
And chloride.
ions. How about a base?
Yeah.
Sodium hydroxide makes sodium
Na plus
and hydroxide.
and OH minus.
Right. So let's look at a movie.
Ooh.
It's not really a movie. It's an animation.
Yeah.
Right. And it's going to help us understand what it means to be dissolved.
Dissolve.
Oh, let me move my scribbles out of the way.
Because our kids knows what is it. But,
Yeah. So let's look at salt dissolving in water.
Mhm.
So first we put the salt in the water, and it's going to be just like a clump of salt
Yes.
in there, right?
Exactly.
And then we stir it around, but all the salt particles are stuck to each other.
Yeah.
But then the water molecules are called polar molecules because one end of the molecule has a negative charge.
Negative charge and the other one is positive.
Yeah. And so because opposites attract, then the water is going to surround the sodium chloride this way. Look, the negative end here is attracted to the
To the
positive.
positive.
Right. And then the water turns itself around where chloride is negative.
Mm-hmm.
The positive side with the hydrogens
Yeah.
is going to stick on the chloride because opposites attract.
Yes. And then what happened?
My scribble's in the way. And then more water comes around
Molecules, yeah.
it. Right. This is called hydration,
Mm-hmm.
right? Like hydrating, drinking water.
Yeah.
Well, hydration means that the ions get surrounded by water.
Yeah, surrounds.
And then they don't stick to each other anymore.
Exactly.
That's what it means to be dissolved.
Dissolve.
So when you're making Kool-Aid at home and you stir it around in there,
Yeah.
it's not really dissolved till every single particle is surrounded by water.
surrounded by water.
Yeah.
Hmm.
That's it.
That's cool.
Yeah. So what does that mean for us? That means if we tell you something's dissolved in water, that means it doesn't stick as a molecule.
Yeah. Now they can explain that to their
Yes.
young brothers and
That's right.
sisters. Yeah.
And their parents too.
Yeah.
They exist as a charged particle.
Uh-huh.
That's why salt solutions tend to conduct electricity.
Yeah, because of the negative and the positive charges, right?
Yes, it carries electricity through.
Yes.
Okay, let's look at the solubility rules then.
This is very important, guys.
Because not all ionic compounds dissolve in water very well.
Exactly.
I have to sneeze. Okay, let's look at this table that is in their notes packet,
Mm-hmm.
in their packet for Unit 7.
And I think it is also in their book, right?
It's in their book.
Okay.
That's where I got it from.
All right.
And it will be printed on their test too.
All right, cool.
Okay, so you get to use this chart to help you remember the solubility rules.
I hope they're going to use that.
Right. So one type of salt that always, always, always breaks apart is
the alkali.
Yeah, salts of alkaline metals like lithium,
Mm-hmm.
potassium, sodium, right? All of those. Why did I put a mark there? Ignore that mark. Yeah, those all break apart. And then ammonia, it says ammonia, so you could interpret NH3, but also ammonium follows this same rule.
Okay.
Okay? And these are always soluble.
Soluble.
So we would write AQ.
Not S.
Right. S doesn't mean soluble. S means solid.
Solid.
Yeah. So AQ because they dissolve in water.
In water.
So every time you see these things in the beginning of a compound, AQ.
They dissolve in water.
Right.
Yep.
Anybody in group 1. Nitrate salts and chlorate salts are the same. So NO3 is nitrate. Chlorate, ClO3.
ClO3.
And then also acetates are soluble.
C2H3O2.
Yep. So nitrate, chlorate, and acetate always AQ.
AQ.
Right. The sulfate salts are those with SO4 that has a 2- charge. And most of those are soluble as well. But this one has some exceptions.
Yes.
You see where it says
So
except?
pay attention.
So these exceptions are the ones that are solid. They don't dissolve. They stay as a powder in the bottom. And so they are silver, mercury, and lead. Silver, mercury, lead. And then barium, strontium, and calcium.
Yes.
And I have to say them in the same order every time or I don't remember. Silver, mercury, lead. Strontium, calcium. I don't know why. Okay, then chloride salts are mostly soluble. But we have some exceptions here too.
Yes.
They should look familiar.
Again, mercury.
So, right. You have to say them in order.
Yeah.
Silver, mercury, and lead.
Okay.
Yeah.
Silver, mercury, and
lead.
Lead.
Yeah. I can't say them out of order. These are the ones that are solids, not aqueous.
Okay.
Okay. Almost everything else is insoluble.
So those are the only things that they need to remember.
Yeah, like, well, let's see, 1, 2, 3, 4 things that are soluble. Remember the exceptions to the rule.
Yeah.
And everything else is insoluble. But notice it says most.
Most.
Because we apply the rules in order from top to bottom. So if you have a carbonate, there's our carbonate, right? If you have a carbonate with, say, iron, that's going to be insoluble because it says most are insoluble.
Oh, yes.
But what if you had sodium carbonate? We apply the rules in order.
That's
and
soluble.
Sodium is always soluble.
Yeah, because Na is soluble.
Exactly.
Cool.
Yeah. So if you have any of these, carbonate, phosphate, chromate, sulfite, any of those, with an alkali metal or with ammonium, it's aqueous.
They're always aqueous. Okay.
Right. So let me teach you some tricks.
All right, I want that.
You've already seen my tricks, but the students haven't seen my tricks.
Yeah, but I kind of forget about what is it. But so I wanted to learn it again.
Okay. Let me show you the name of my trick.
Oh, I remember this.
The trick is named Knuckle No So. It sounds silly.
Yeah.
But silly things help us remember. So,
Yeah.
Here's
You're
my
right.
trick. Sodium is always aqueous. And anybody in sodium's family is aqueous. So this is group 1 and ammonium.
NH4.
They're all aqueous. And here's how I remember. It's not going to hang out in solution with anybody else because does anybody want to hang out with sodium?
No.
Nah. Nobody wants to hang out that way. Poor sodium has to hang out by himself.
Yeah.
Aw. Then chlorine is always aqueous except for, we have exceptions. So not silver or, oops, I almost wrote the word mercury. Hg is mercury, or lead. Those are the exceptions. These are soluble.
Hmm.
Everything else dissolves in water.
All right.
Okay? Then we have the nitrates and the nitrate families.
Mm-hmm.
So aqueous,
Aqueous.
and there's no exceptions.
Okay.
Okay? So everyone in the nitrate family acts this way, so that was nitrates, chlorates,
Chlorates and
acetates.
yeah, CH.
C2H3O2. Right. So all of these guys are aqueous, and here's why. Does anybody want to hang out with nitrate?
No.
No. Nobody
Nobody.
wants to hang out with
No.
nitrate. Sad. Or chlorate or acetate.
Yeah.
And so one of my students taught me it's the nose, the close, and the chose. They don't want to hang out with anybody.
Yeah.
All right, now let's look at sulfate. Sulfate is always aqueous.
Mm-hmm.
But we have some exceptions. So these guys, silver, mercury, and lead, I call these the three amigos.
Okay.
They're the exceptions.
Mm-hmm.
These are my three amigos. But with sulfate, I have a gang of 6.
Whoa.
So it's not just silver, mercury, and lead. They have 3 more friends. Barium,
barium.
strontium,
Mm-hmm.
and calcium.
All right.
These are also solid in solution. They don't dissolve.
They don't dissolve.
Okay, now let's look at hydroxide. These are usually solid,
Solids.
right? But I have an exception.
Mm-hmm.
My exception is my group 1, my nah. Nobody wants to hang out with sodium.
Yeah.
Nah, right?
Yeah.
Oh, group nah? No, group 1, sodium. And also these guys. These 3 culprits, barium, strontium, and calcium, they're exceptions here too. These are always soluble.
Soluble.
So anything in group 1 plus barium, strontium, and calcium, they're aqueous.
They're aqueous.
Yeah,
All right.
because they make strong bases.
Exactly.
So those are the solubility rules. Let's
Right.
use them.
Yep. And
'Cause-
remember them all the time.
So we're going to show how we would use these.
All right.
Okay. So first of all, it says circle all the ionic compounds that are
insoluble.
insoluble. That means they have S.
Mm-hmm.
So these are what we call precipitates
Precipitates.
in a solution. Remember when we mix 2 clear liquids?
And they're
they
going to
turned
settle
yellow?
at the bottom.
Yes.
Yeah.
Right. So those are the ones we're looking for.
Okay.
So fluorine follows the chlorine rule. Fluorine is in the same halogen family as chlorine. So our 3 amigos are the only ones that will be S.
Okay.
Silver, mercury, and lead.
Mm-hmm.
Magnesium is not one of those.
Yes.
So we can't circle that one.
Yeah.
Okay, now we're looking at the sulfate. Remember the gang of 6?
The gang of 6, yeah.
Silver, mercury, lead, barium, strontium, calcium.
Cu is not one of them.
Nope, copper's not one of those.
Okay.
Okay, now here's chlorine and ammonium.
Ammonium.
Remember ammonium?
Yeah.
No one wants to hang out with him.
Yeah.
So we can't circle that one.
Okay.
Okay, hydroxide. Our exceptions would be the ones that are soluble,
They are soluble.
right?
Like
so
the 3 the 3
the barium,
the
strontium,
barium, strontium,
calcium, and then also group 1. Iron's not in group 1,
No.
and it's not barium, strontium, or calcium.
Yes.
So this is solid
Mm-hmm.
in solution. I'm going to circle this one.
Because it's insoluble.
Right, exactly. Okay, here's fluorine again,
Mm-hmm.
but it's with an alkali metal. So you see them as group 1.
Yes.
So no circling
No
there.
circle.
Silver chloride. Chlorine had silver, mercury, and lead.
Mm-hmm.
So we better circle that.
That's
Insoluble.
insoluble.
How about sulfur? Do you remember the sulfide rule?
Yeah.
So it's only soluble if cadmium.
Oh yeah, they're the last one, right?
Yeah.
They're in the last rule.
Right. So if you see something you don't recognize from any rule I just taught you in knuckle no so
Mhm.
wait, I forgot the other O. Knuckle no so then it's insoluble.
Yeah.
Okay, fluorine follows the chlorine rule.
Mhm.
Silver, mercury, and lead.
Yeah.
Copper's not one of those, so I
Yeah.
can't circle that one. Sulfate.
Sulfate.
Let's see,
And
our 3
PB.
amigos, right?
Yeah.
PB is
PB,
lead.
yeah.
That's one of our 3 amigos. Oh, barium hydroxide. Barium was this
Mm-hmm.
exception.
Exception.
But for hydroxide, the exceptions are aqueous.
Aqueous.
So I can't circle this.
Yeah.
Okay, let's come down here to sodium sulfate.
Sodium sulfate.
Anyone want to hang out with this guy?
No.
Nah. So that's not going to precipitate.
Precipitate, yeah.
Ammonium is in the same boat,
Yep.
right? That's a
Mhm.
nah.
Nah.
And then strontium, barium, strontium, calcium. Oh, but look, here's nitrate.
Nitrate.
Anybody want to precipitate with nitrate?
No.
No. Silly. We can't circle that one. But I put a box around it. No big
Okay.
deal. Okay. Mercury.
Mercury.
Uh-oh. Remember Mercury is one of our
Yeah.
three amigos.
Yeah.
And iodine is a halogen like chlorine.
Yes.
I better circle this one.
Yeah.
All right. Sodium is nah. Don't circle
Exactly.
that.
Yeah.
Barium carbonate.
Carbonate.
Does the carbonate have the rule that hydroxide does for
Yeah.
barium?
Yeah.
No, only hydroxide does.
Oh yeah. OH.
Carbonate, that's insoluble.
Yeah.
Unless it's with an alkali metal like sodium.
Oh yeah.
All right. Oh,
Exception.
here's our three amigos.
Three
Lead
amigos.
is one of our three amigos. Bromine acts like chlorine,
Yeah.
so that is solid. Calcium oxalate.
Oxalate.
We talk about oxalate.
We talk about that?
Nope.
No.
So we better circle it.
Yeah.
To the best of our knowledge,
Yes.
that will precipitate.
Yeah.
And it does.
Then you have
we have acetate.
acetate. Acetate.
The nose, the clothes, and the chose.
Oh yeah.
This is my cho.
Mm-hmm.
So that's aqueous.
I need to remember that, Miss Gray.
I think, last year a student taught me that trick.
Yeah.
Okay, magnesium oxide.
Oxide.
This isn't hydroxide, it's oxide.
Yeah.
We learn a rule about oxide?
No.
So I'm circling it.
Yeah.
But we made this in class. Remember, we burned magnesium
Mm.
and we made magnesium oxide. It's that white
Yeah.
powder that doesn't dissolve in water.
So it forms precipitate.
All right, so that's how we use the solubility rules.
Okay.
I think that's the end of our podcast. Oh no, we have a little bit more.
So
Oops.
writing ions.
Yes. So I wanted to practice when we see that something says it's aqueous,
Yeah.
how do we write it?
Yeah.
So if I have sodium carbonate, I have to use my naming card
Mm-hmm.
to see what is the ion
Ions.
for sodium
Yeah.
and what is the ion for carbonate.
Carbonate.
So on my naming card, sodium looks like this,
Na
Na with a plus.
Plus.
And carbonate is
CO3 minus.
2 minus.
2 minus.
But because this is a 2 minus, how many sodiums did I need to hang out with carbonate?
2.
Yes. So
So
the 2
two.
goes in front. This 2 is going to move to the front. Because on the ion card, there's no such ion that looks like this.
Yeah. No.
That doesn't exist. But you can have 2 of these.
Na plus. Yeah.
Yeah.
To hang
so
out with.
Yeah, to hang out with a carbonate and make it add up to 0.
Okay.
Okay, so we have to move that subscript over. Let's check our work. Did we do it right?
Yes.
Sure enough.
Yeah.
Well, let's practice again because I want our students to get good at this.
Yeah.
When the ions
It's very
form
important.
from the molecules,
Mm-hmm.
they separate the charges, but the overall total charge has
Must
to
be
stay,
stay the same.
and the number of atoms has to stay the
Yeah.
same.
And they need to check that, right?
Yes.
Mm-hmm. See if
All
their
right.
answer is correct.
So let's look at this one.
Okay.
Calcium phosphate.
Is that Ca?
And
Ca plus? 2 plus?
2 plus, it's
Mhm.
group 2. And then
Then
PO4 is
PO4.
phosphate,
Mm-hmm.
and that has a 3 minus
3
charge.
minus charge.
Because, look, if we undid the
Undo the
crisscross
crisscross.
rule, we'd see what their charges are.
Yeah. They
Yeah.
need to remember to undo the crisscross.
And how many of these did I have? This 3
3
tells me how many calciums I had.
Mm-hmm.
So I have 3 calcium ions.
Yeah.
And then the 2 tells me how many phosphates.
Yeah. So you have
I have.
2.
So when I separate this molecule, calcium phosphate,
Into ions.
into ions, we get 3 ions of calcium
Mm-hmm.
and 2 ions of phosphate.
All right.
Ready for cadmium nitrate?
Okay.
All right. What's the charge of cadmium?
That should be plus. 2 plus.
Right, we'll use that.
2 plus.
2 plus. How many of
And-
them are there? How many cadmiums in this formula?
There's only 1.
Oh, do I have to put a 1 in front?
No.
All right then.
Plus.
NO3, is
NO3.
nitrate,
Mm-hmm.
and
It's
he's got
minus.
minus 1 charge. How many of them are there?
2.
Okay, so I'll put the 2 out front.
Yeah.
This comes up in front because there's 2 of them.
Exactly.
All right, that's all we do.
Oh, that's easy.
So if we have
It's
example
okay.
1, I'm willing to bet there's an example 2. What do you
Okay.
think?
I think so too.
Probably so. That's how I roll. Okay, let's do it again.
Yeah.
This is sodium sulfide.
All right.
So sodium we already know is a plus
It's
one.
a plus 1.
How many of them?
2.
Radio. Do you know the charge of sulfide?
It's 2 minus?
Mm-hmm. Because we undo the crisscross. Right?
Yes.
Okay, now let's do magnesium borate. You probably don't have borate on your naming card. That's okay. I can find its charge right here. Undo the crisscross.
Oh, yeah.
Right?
They just need to remember the crisscross thing. I love the crisscross thing.
It works. It works.
All right.
So
I bet that's 2 plus, Miss Gray?
Yep.
Mm-hmm.
And then borate, BO3.
3 minus?
You got it.
All right.
Now let's put how many of them there are.
Okay.
Be careful. This 2 is the charge of magnesium, but there's 3 of them.
Yeah, so 3 Mg2 plus.
Mm-hmm.
And then I should have 2.
2 borates.
Yeah.
Right, because overall the charge has to add up to 0.
Exactly.
So if I have 3 of these and 2 of these,
Mhm.
then this is a 6 plus, and this is a 6 minus,
Mm-hmm.
so that works.
Exactly.
Well, that's it for the solubility rules.
Piece of cake.
I know. Nice doing a podcast
All
with you again.
right. Remember the crisscross to
Yep.
know the